Right. I left class on last week by trying to write a new and improved version of the class roster. And I made it to some point, and I ran into some problem, and that's always awkward trying to debug code in front of people. So I took it back to lab, and literally within a few minutes, I had the answer to it. And anyhow, I posted that on Canvas, but I wanted to review that today before we go on to the next thing that we're going to cover. So, again, to refresh our memory, this is, I think, labeled as roster 1. So when you run this under courses, see a listing of course, department, the instructor that's teaching it, and a list of students. And functionally, I haven't changed this. This gives me the same information that it always gave, and it gives me the same information that roster changes it. But it's better code. And that's one thing I want to emphasize. You know, there's a saying, it's something like, do the best you can. And when you learn more, then do better, right? So therefore, code that works is okay, but if you can find ways to make improvement to code, you should take advantage to them. And it's not always like, you know, you don't finish a project and be done with it for the rest of your life. You know, oftentimes you're revisiting projects and you refactor code. That is, you make changes to it. And that's what I did in this case. I didn't like, it seemed kind of like messy logic in the previous version. So I went and cleaned up the logic. So let's take a look at that briefly before we go on to today's topic. So under courses, roster 1. We're going to start looking at this. Okay. As I'm looking at it, I can see possibly even other improvements I could make. But in this list, we need courses, department, instructors, or enrollments. And I've changed the query to say, get stuff from C in courses where the IDs match, select, and create a new object that contains a course object, a department object, an instructor object, and an enrollments object. Let me rephrase that. The instructors and enrollments are lists, not objects. The department is a single object and the course is a single object. Then I'm going to loop through all the enrollments in the enrollments object, and I'm going to look up the student and populate the student. That's very similar to what we did in the one example that we saw previously. Then when I display it, I loop through, and for each instructor, I loop through and display the full name. For each student, I loop through and display the enrollments record and the name for the enrollments record. I probably even change this. Again, this is risky, right, to do some live coding, but I could probably get rid of these. And change this to say, model course department name. for each and model course instructors for each and model course enrollments. And it should work the same way. I can get rid of those additional objects. If I completely get rid of them. Maybe not. Okay, never mind. Scratch this. Again, I don't want to work through this, and I won't work through this, but this would be the path of being able to get rid of that code. Let me just take one quick look at it. Yeah, so scratch that. I'm going to keep these in here, and we'll do it that way. So I'm actually going to restart the class and omit that part. So only you people seeing it live will see that screw up. So
You're doing well.
take two. All right, I made a new improved version of roster. Okay, and what I did is I rewrote the query for roster one to do this as a query. I'm pulling from the courses, all right, where the ID matches, and I'm pulling the courses C, and I'm pulling the department for C and stuffing it in this object department. I'm pulling a list of instructors and creating other list of instructors for the course and stuffing that in a variable called instructors. Or that's ultimately where it's going to end up. It goes to this intermediary field first. Finally, the same thing for enrollments. And then I populate those model variables up here. And then when I run it, I pull from the department the name, I pull from the list of instructors, a list of full names, and I pull from the enrollments, the enrollment that has been populated with the student name. So take a look at this code. It's a little bit cleaner code in my opinion, and I like it. And there we have that. So this is a better way of doing it. I did the query better, and changing the query made me change the actual display of it. So take a look at that, study through it, and see what I did with this. This is using the query syntax, where I do a query and I populate these variables in the result set, which is called course stuff. And then I take the variables from that course stuff and I populate it into these individual objects that I'll use on the main page to display the data from those particular entities. All right. So I just wanted to show you that I did do that. I started to do that in class last time. I got part of the way through it and got hit with an error. Didn't want to sit in class debugging, so I took it, went in lab, and the source of the error was obvious for me after I looked at it for a minute, and I made the change and posted it, but I wanted to review that again today with you. This kind of stuff is key, whether you use the method that I did with the method version, or you use the query version. The idea of populating these objects, like in this case, I use the include to populate the department object associated with the course, the instructors associated with the course, and enrollments are the keys to writing good queries. Okay, because we want the queries such that they combine stuff. That's one of the ways that you can take raw data and transform it into something more usable, is combine data together from different sources. It's okay to have a list of courses and all that, but a course list that includes the name of the instructors, the department, the list of students is much more useful probably for people within the organization. So take the time to understand these queries and to understand how we then go and loop through that object that we retrieved and loop through to get the list of course instructors, the list of enrollments, and so on. So that's really important. That will be very important when it comes time for your project. All right. Here's the main topic for today. And the main topic for today is called design patterns. And I have some resources in Canvas that talks about design patterns. All right, and this defines what design patterns are, and it gives you a list of typical patterns. So you can look through these. When design patterns was originally come up with, they had a few, and then they've added some design patterns since then. Did it ring a buzzer or something? Or all right. Anyhow, the idea of a design pattern is stated clearly up here at the beginning. It's a typical solution to common problems in software design. Each pattern is a blueprint you can customize to solve a particular design problem in your code. This is a great chance for me to kick back and talk about how it was in the early days of programming. Because I wasn't necessarily a pioneer in programming. I had come on after programming was around for a while. But I was still in the early days of programming compared to now. And programming was a lot less sophisticated, I think, than it was now. Because everyone crafted solutions for their problems. And they crafted their own sort of way of solving them. So every organization, every programmer might have a different way of looking at the same problem and developing it in a certain way. And they did what they could to make it work. And they weren't interested in things like consistency, maintainability, things like that. The focus was getting the job done and maybe getting the job done efficiently with very efficient code. So therefore, people developed all sorts of solutions. And maybe there was some consistency within an organization. So maybe one organization solved the same kinds of problems the same way. Or maybe there wasn't. Maybe there was not even consistency except for individual developers. This is analogous to the time when people made wagons back in the olden days. And each blacksmith would craft a wagon wheel by hand, and each one was a custom job, right? And you have to imagine how tedious that was. I don't know how you make a wagon wheel. I think you take metal and you heat it up and I don't know, you do something, you turn it into a circle somehow, all right? But each one did it their own way and came up with their own solution, and each individual solution was crafted more or less starting at ground zero, starting from scratch. You did everything from scratch. At some point, and I don't remember when this historically started, but there was the idea of design patterns. The design pattern is to say, look, every programmer has certain problems that they solve. All right. So why don't we come up with some blueprints to say this kind of problem you solve this way, this kind of problem you solve that way. Let me see if I have the Wikipedia entry. See when it was created. $1994. So I was I was into my programming career by that point. All right. Yeah, I know everyone's looking, it's like, oh my God, how old is he? But yeah, I had been programming professionally for 10-ish years up to that point. All right. But the idea of this that they developed, someone developed a book, these folks here listed here developed a book to say, hey, we can provide some templates for some common face problems. All right. So that's the whole idea of design patterns, that we give these we give these templates or blueprints for some very common problems. So how is that relevant to this class? And I have a list of design pattern examples and all that. One of the, what we've been doing this semester is using a specific design pattern called this. Let me see, I want to open up Paint, I think. MVMM stands for Model, View, and View Model. All right, that's what we've been doing so far. And there's a one-to-one relationship between View and View Model. So if you think about this, it might be clear how we've been using this pattern. Because if we look at our code, like for example, from that database, let's close out of it. Model is this stuff. The model relates to the stuff that's stored in a database. And you could also have business rules in the model too. You know, like you could have a validation if a certain value needed to be within a range of values or something like that. You can put business rules in these too, but this relates to the storage and business rules associated with each of these entities. So that's the model. What is the view? The view is how the user sees the data, how they view it. What is the view? It's the CSS_HTML pages. So in the model folder, We have the .cs files. The view is in the pages folder, CSHTML. And what is the view controller? What has a one-to-one relationship with the CSHTML? CSHTML.cs. So, in short, for course, let's say, for example, this is a model for course. For courses, we have a view index.cshtml, which displays a listing of courses. And we have the page model, which is the .cs file associated with that. So what do all these things do? What do all these things do in the model view model? They do the following. Model contains the fields, how it's connected to the database, the attributes, and maybe some business logic. And I say business, even if it's not a business, if it's a program domain or problem domain, that counts as that. So that's the model. The view is what the user sees, the user interface. The controller sort of is the glue between these two entities, between the model and the view. And sure enough, if we look here, you know, the CSHTML page says what the view is going to look like for the user interface. Here's the model for course. This is the data that's stored in the database and all the attributes, and we could have business rules, if any. The thing that connects those two is the page model, or the page, yeah, or the view model rather, or the page model, however you want to put it. Because if you notice, this connects it. This goes in and this uses the model and to provide some data that in turn the view can use to construct the view and construct the user interface. So even though we didn't name it that, that's what we've been using. And if you notice, it works for a lot of situations, right? We have the same, we do courses the same way we do instructors. The instructors the same way we do students, the same way we do departments and all that. We have a template, a blueprint for creating entities and views associated with those entities in this environment. So it's a good thing. Instead of everyone doing it their own way, you know, in no predictable way, where if you look at my code, you won't make any sense of it. Anyone that has seen Razor Pages and knows a little bit about it could look at this code and make sense of it, right? And that's a good thing. Like, let's say, for example, we have a couple people in class today. Let's say if one of you was the original programmer on a project, then you went and got a better job, and one of the other of you had to take control of it. Since a design pattern was used, it's easy for you to go in and look and say, okay, that's what they're doing. This is the model, this is the view, this is the page model or view model. So that adds to maintainability and repeatability. It turns software from more of a craft to more of an engineering sort of project, because there were standard approaches to standard problems. And all those things are good things as far as maintainability and What's more, even if you hired someone in from a different organization, if they understood Razor Pages and they understand the VW or MVVM model, they could go and they could take this and they could maintain it. All right. So why am I talking about this now? I'm talking about it now because we're about to look at a different model. And this is a different way of creating Razor Pages. And it's similar, it's similar but different, right? And that view is called the MVC approach. Now, some of you may have heard of this before. Well, the M and the V stand for the same thing. And they serve the same role. The model, still the model. View, still the CISS page. What's different is we have a C, which stands for controller. And what is difference between MVC and MVVM? Well, we have one view model per view in MVVM. We have one controller per entity in MVC. So when you look at this, you're going to notice the stuff that you're going to put in the controller is like all the stuff that was in all the different view models. For a given entity, we put all the code that's in there for a given view model. Let's ask our friend ChatGPT, compare and contrast MVVM with Model View Controller. Compare and contrast MVVM and MVC. Most architectural patterns, design patterns. Here's a comparison. It's kind of what I said. And oh yeah, by the way, just as the view model is the glue between the view and the model, the controller is also the glue between the view and the model. Intermediary between the model and the view. Also a mediator between the view and the model. And so on. Key differences. MVVM, we can bind data together. I don't know if we used any data binding examples in this class, but that's something you can do to write code that takes and binds the data. Actually, we do that with the model. We can pull the attributes. Like in the case of course example. We look at our view model. We define a course object, or where is it? Here. We define a list of courses. Well, that list of courses is connected to the CSS, and we can pull things from that. All right, so the data is bound, whereas you explicitly have to write code to update the view in MVC. MVVM tends to be more testable than MVC because the view model is independent of the view. Ease of maintenance, MVVM can lead to cleaner separation of concerns. And then there's a summary. MVVM, as you can see, is sort of a evolution of model view controller. But some places still use that paradigm of model view controller. And therefore, we want to at least do one exercise in it to make us familiar with that. And let me pull up that exercise. This will be a pretty easy assignment for you. As I mentioned in all my classes, one of the reasons that I go over some of these things, even if we don't stress them, is just so that you're introduced to these concepts. It would be bad in my mind if you went to work for a place, a .NET shop, and you had never seen a model view controller approach because maybe they use it at that. So even though we're not going to dwell on it, we're going to at least view one example so you can say if you got that hypothetical job, oh yeah, I remember this. At least that's the hope. All right. Now there's a tutorial to do the movie example, just like there was a tutorial to do it using MVVM. This has to be tongue-tied. So, getting started with ASP.NET Core MVC is a tutorial. And this should look awful familiar for you. Create a web app. I'll follow through some of these steps. I won't go through the whole thing because I don't want to spoil the fun for you. I'm going to create a new project. And instead of picking what we had picked before, which was this one, we are going to pick this one. Very similar, but they're also different because this uses the MVC model. They suggest calling it MVC movie, and so we're going to do that here. Put it on the desktop. What version do we want? Authentication type, we're going to do none, but it would be very similar to what we've done with our Razor pages. And we're going to click create. So we have something very similar to what we had before. The difference is we now have a controllers folder, and we have a models folder. Okay, we can run this. And we see the same thing pretty much that we saw before, an empty application. Okay. Next, we're going to add a controller. All right. Now, the controller is going to be the go-between between our model that we create and our views. So let's go in here and create a controller. So I'm going to right-click, add a controller, and we're going to call it the Hello World controller. Empty. And we're going to put the following code in it. Okay. So we have this controller. What does that mean? That means when we run this, if I add in the name Hello World, that is going to be the name of the controller that gets called. So I go and run this, get my default page. If I call Hello World, I get outputted, this is my default action, just a string. So at this point, we're not creating a web page yet. Our controller is just outputting something, all right, a return value. Of course, that's going to change, right? Because what we're going to do next, I think, is is to create a page. Fast forward through this. Reviews, I'm going to add a folder. For MVC movie. Right mouse and add a view. Empty, and we'll call it index.cshtml. So here's our view. Now this is very similar to what we had before, except now there's no view model for this because the controller serves that role of the view model. And we can go in and we could put code in here just like we put in there before. So we could go in and say a paragraph. Type. This comes from the view. So what we have to do though is return this or modify our controller to return view. See, am I looking at the right thing? Typing wrong. Oh. How does it know what view to do? Based on this. The method in here is called index. Therefore, that is going to go and it's going to return that index view. Click on this. We go to Hello World. We're not supplying a URL after that. Therefore, it knows that we want the index. The controller knows that because we're calling this controller. Since we're not supplying a URL after that, we're getting the index. Which calls that method and returns the view. What view does it return? Index.cshtml. Or it gives us an error. The view index was not found. Oh, I know what I'll bet I know what I did. Oh, that should be Hello World, not MVC movie. That's my mistake. That makes sense because it's the name of the controller, right? My mistake. That makes sense. I don't know what I was thinking. Oh, there we go. I went and cleaned it. Sometimes when the project gets messed up, if you just run the clean, it will find what's wrong. I'm thinking that because I originally made that mistake, something thought that it needed to be in the other folder. But when I cleaned it, it fixed that up. But this comes from the view. All right, you can almost predict the way the rest of this tutorial is going to go. Because at a certain point, and this adds a bunch of stuff to the view, Nothing terribly exciting. Here's where the fun starts, because we're going to create a movie list, just like we did before. And this takes you through the process of adding a data model, which should be the same as with a Razor page, probably identical code. I don't know for sure. We're going to add the NuGet packages if we need them. We're going to scaffold our pages. The difference is we're not going to pick Razor pages. We're going to pick MVC controller with views using Entity Framework Add. We're going to do our initial migration, update the database, and we're going to test the app. So the rest of it's going to look very, very, very familiar. The only difference is instead of creating a different view model for each page, you're going to have everything in that one controller. So that is, I think, lab 12 for you to go in and run through this tutorial and get it working. Essentially, you'll have the same thing that you had with the first tutorial that we saw around week 4. The only difference is in this example, you don't have to add the actors table. You can just you can just do the movies table. Now, look on Canvas, because I am thinking that I need to double check to see if I've covered everything that I want to cover. If I have, then the next 3 weeks will be a time for you to catch up on the assignments and to focus on doing your project. But take a look at Canvas. By the end of this week, I should know exactly what I'm going to do. If I need to lecture some more and have another assignment, or if I'm just going to say, well, just catch up on what you haven't done, but spend a lot of time working on your assignment. So I'll let you know via Canvas. So take a look at that, and I will post by the end of the week how things are. Are there any questions? Yeah.
Okay, so this is supposed to be the last class where we're going to learn something new.
Oh, I am thinking,
Really?
yeah, that the last 3 weeks, you may learn something new, but it's going to be based on your own investigations of what you need to do. Like, let's say, for example, you want to store an image in a database, all right? Or you want to store the name of an image file. How can you take that and display an image from it, for example? That might be something that you maybe don't know how to do offhand, and you'll learn. But the stuff for the rest of the semester, I believe, will be stuff that you're going to learn by trying to do stuff in your project.
Okay.
Other questions? All right, we'll either see you in lab or we will see you next week.